Thank you for joining this lesson. We're going to discuss differentiation and its application in kinematics. Number 19, the displacement S meters of a moving particle from a fixed point O after t seconds is given by S equals to t power 3 minus 5 t squared plus 3t plus 10. Part A, find S when t equals to 2 seconds. So when t equals to 2 seconds, we can find the value of S by simply substituting 2 power 3 minus 5, t is 2, so we square it, plus 3t, so t is 2, then plus 10, and this will give us exactly 4 meters. The next question is talking about determine the velocity of the particle when t equals to 5 seconds. Velocity will be given when we differentiate displacement with respect to time. Remember, differentiating displacement will give us the gradient function of the displacement when plotted against time, and in a graph of displacement against time, the velocity is usually given by gradient. So it's good, or it's advisable now we find gradient function for the displacement function which has been provided, and that will be equal to the velocity function. So when we differentiate this, this is 10 power 3 or t power 3, so 3 drops there, so it's 3t, and the power reduces to 2 minus 2 again multiplies the constant, which is a negative 5, so it's negative 10 t plus 3, which is multiplied by t power 0, remaining the way it is, and the constant disappears. So this is now the velocity function. When we get the velocity function, the next thing we should do is now to find the velocity value at t equals to 5. So 3 into 5 squared minus 10 into 5 plus 3, and this will give us exactly 28 meters per second, of course, because it is velocity now. Part 2, we are finding the value of t when the particle is momentarily at rest. This is the time when the particle is having 0 velocity. So we will take the velocity function and we equate it to 0, and this will help us to get the value of t now when the particle is having 0 velocity. So 3t squared minus 10t equals to negative 3. We can divide by 3 first of all, because the value of t squared must be 1 when solving using what we call the completing square method. We have divided everything by 3. The next thing is to add a constant now to both sides. We add a constant here and a constant on the right hand side. The constant c is usually given by the negative b out of 2 squared. So negative 10 over 3 divided by 2 means times half, then we square, and this will give us 100 out of 36. So we should add 100 over 36, 100 over 36 to this other side. So at that step now, as I add the right hand side, I will be able to factorize the left hand side. To factorize a perfect square, we usually take the square root of the first part, which is t, the sign which follows, which is a minus, then the square root of the constant, which is going to be 10 out of 6 squared. Now the perfect square has been factorized. Then on the right hand side, negative 1 plus 100 over 36, that is going to give us exactly 16 over 9. So the next thing now is to take square root from both sides. T minus 10 over 6 will be equal to plus or minus 4 out of 3. And the value of t will be given by, we begin by 4 over 3 plus 10 over 6, or t equals to negative 4 out of 3 plus 10 out of 6. Then the first value of t is going to be exactly 3, or the second value of t will be a third, seconds. Finally, we are told to find the time when the velocity of the particle is maximum. And we should say that velocity of a particle is usually maximum when acceleration equals to 0. So when a particle was fully accelerated, it attains maximum velocity. So we are saying for a particle to be said to be having maximum velocity, it attains such a velocity at 0 acceleration. So now we should find acceleration function, which should be found by differentiating velocity with time, because the gradient function of a velocity time function gives us acceleration. So we should find gradient function of a velocity function. Because the velocity function is already here, we're going to integrate to differentiate it, So the power of t, which is 2, multiplies the constant, which is a 3, we get 6 power t, then minus 10, and the constant 3 disappears. So at this point now, we can equate the acceleration to 0, such that we get the value of t when acceleration equals to 0. And now we're going to say the value of t equals to 10 out of 6, which is 5/3, which is 1 and 2/3. So seconds, of course. So that is the value of time when the particle is having maximum velocity.